Sir. Hello, hello. Hello. Teacher. Mr. Hamza. Mr. Hamza.
Hello? I'm muted. Eh?
Yeah.
Now you can hear me.
Yes.
Oh, sorry.
Yes.
I was saying, if the system is released, the heavy mass will go down. Then this lighter one rises up, the 4G. Then on the horizontal table, T2 will overcome T1 to give us the resultant force on the 10 kilogram mass. It was 10 kilograms. So I got the equation of the resultant force on 7 to be 7G minus T2 is equal to 7A. Then this T1, the T1 was overcoming the 4G. It overcame this one. So T1 overcame 4G to give me 4A. Then horizontal table T2 overcomes T1 horizontally to give us a resultant force on 10, which is 10A. Now with that, I can eliminate T2 using Roman 1 and Roman 3 by addition. So add Roman 3 to Roman 1. This will give me 7G, stop shaking, 7G minus T1 is equal to, because we added, we shall get 17A, and I'll call this equation star. So I can add equation star to Roman 2. I add equation star to Roman 2 so that I can have T1. Let me show you this T1. So that I can have this T1 added to this T1 to eliminate the T1s also. So when I eliminate those T1s, I'll have, others can use substitution method. You make T1 the subject, drop it there. So we shall get 7G minus 4G is equal to 4A plus 17A. This gives me 3G is equal to 21A. Therefore, my acceleration is going to be 3G out of 21. And the answer becomes G out of 7, which is equal to 9.8 divided by 7. If they don't tell you to leave G in your answer, you have to go as far as this and get 9.8 divided by 7 to give us, what do you get with a calculator? 9.8 divided by 7, you get 2 point what? 2.4, sorry, 1.4. You get 1 remainder 2.8, which is 1.4 meters per second squared. So having gotten the acceleration, you can come like here and make T1 the subject. So to make T1 the subject, you make, for example, 7G minus T1 is equal to 17A. So T1 is equal to 7G minus 17A. But you have attained A already, so 7G minus 17. The A you have attained is G out of 17. Sorry, it is 3. It is G out of 7, not 17. So this will give us 49G minus 17G divided by 7. And this gives us 32G over 7 newtons. When they ask you to remove G, you substitute for 9.8. Then consequently, we can have also T2. Either T2 you use this one or you can use the first one. If I use this second one, first one, 7G minus T2 is equal to 7A. So T2 is equal to 7G minus 7A. Realizing 7G minus 7 times G out of 7. I promote this 7. So T2 clearly becomes 6G newtons. So with that, you would have attained both the acceleration and the tensions in the string or in the strings. Unless if someone has a question on that first presentation. So that was number 18. Hey, stop running. Huh? Have you heard? Are you crying? If you're crying, come and get in the car and lie down. Guys, any concern? I want to give you another one. Now, this other one is going to come in a word problem. This one, the diagram was drawn, but here they can set a number when it's all a word problem without a diagram. Then it is you to interpret what the diagram requires. So the second example will be of a word problem. Let me see. A body or a body A rests on a smooth horizontal table. Two bodies of mass 2 kgs and 10 kgs hanging freely are attached at A by strings which pass over my strings which pass over smooth pulleys. Smooth pulleys at the edges of the table. Two strings are taut. The two strings are taut, meaning they are tight. When the system is released from rest, it accelerates at 2 meters per second. It accelerates at 2 meters per second squared. Find the mass of capital A. Remember, mass capital A is the one that is lying on a horizontal table. Now, this is a wordy problem I was talking about. So you should be able to interpret that it's a table of this nature. So on the side, it has 2 kgs. It also has what? 10 kgs. So there is a mass here, capital A. Whose mass we don't know. So we have tension here, T2. Tension T2, we have tension T1. T1. So when the system is released, they move with an acceleration A, which is equal to 2 meters per second squared. So when A definitely moves on the left, on the right, it moves there because 10 is heavier than 2 when the system is free. So 10G minus T2 is equal to 10A. Then on the 2 kilogram mass, T2 overcomes 2G, T1G, T1 2G, T1 overcomes 2G to give us 2A. But from these two equations, and then also up there we have T2 minus T1 is equal to MA, not MG. We consider horizontal motion, and the resultant force is mass times acceleration. So we can find from these Roman 1 and 2, we can find their tensions. From 1, T2 is equal to 10G minus 10A. And this is going to be 98 minus 20. Why do I say 98 minus 20? 98 minus 20 comes from 9.8 times 10, which gives us 98. Then 10 times 2 gives you 20. So 98 minus 2, you get 78. So ideally, you get T2 is equal to 78 newtons. Then consequently, you can go ahead and get T1. T1 minus 2G is equal to 2A. So T1 is equal to 2G plus 2A, but A is 2. So we shall have 19.6 plus 4. 19.6 comes from 2 times 9.8. So 4 plus 19.6 shall get 23.6 newtons. So finally, I can substitute into Roman 3 to get mass. From Roman 3, T2 minus T1 is equal to MA, and we are looking for M. So it gives us 78 minus 23.6 is equal to M times 2. So you can make M the subject by saying it is 78 minus 23.6 divided by 76.8. When you remove 23, you get what? You get 55. So you shall get 55.4. Giving me 55.4. Divide by 2. When you divide by 2, you get 17.52. 17.5. Press the calculator. 55.4. What do you come up with?
54.4.
You get?
54.4.
No, sorry, 20. 24. Add 55. This is 52. What is this? 54.4, eh?
Yes. Yes.
Like this, eh? So when you divide, you get 27.2. You get that? You get that, right?
Yes.
27.2 kgs. This was mass, eh? This one is in kilograms. So that's how what the problem can look like. Let me do one more, number 3. Put that down. Number 3.
Don't know how. You failed to do it.
This is question 3. I also sent it during the day. And it says the diagram shows freely suspended particles A and C connected by means of a lightning extensible string. So I'm going to sketch the diagram. So this is where A is. This is where C is. In a paper, you have to draw with a ruler. And this is where B is. They're saying, bill which lies on a smooth horizontal table. A, B, and C have masses 3m. So A has 3m. So I will say 3mg for the weight. B also has 3m, so also say 3mg. And then C has 4m respectively, 4mg. This one has a reaction, it experiences R. Find the acceleration of the system and the tensions in the string. So the acceleration of the system here will have tension T2, tension T2. Tension T1 will also have here tension T1. Of course, 4m is heavier, so you expect it to go down unless otherwise. If you choose the wrong direction, you'll get negative answers, but you're marked correct, so no worries. You choose any direction if they don't specify. So we shall have 4 mg minus T2 is equal to 4 m times acceleration. Whenever I set this number, people forget the m, yet the mass was having an m involved. So T2 minus T1 on the B mass is equal to 3m A. Then 3m, you have T1 minus 3mg is equal to 3m A. And with this, we can solve using the same methods we have been using. Equation 1, equation 2, equation 3. So we can add, I can add 1 plus 2. This will give me 4mg. I will eliminate this T2 with this one. Minus T1 is equal to 7ma to give me new equation star. Then I can add the star to Roman 3 or to equation 3 to get this value, to get this T1 combined with this one. So when those T1s combine, shall have 4mg minus 3mg is equal to 10ma. With this, you can see the m is now common. You can divide it off, then you get g is equal to 10a. Our acceleration becomes g over 10 meters per second squared, which is 0.98 meters per second squared. When we get acceleration, we substitute to get tensions. For example, T1 is equal to 3mg plus 3ma. This will give me 3mg plus 3mg over 10. This will give me 33mg over 10 newtons. So with this, the 10 cross multiplies to meet this 3m to give us 30m plus 3m to give us 33g. Then for T2, T2 can be got from 4mg minus 4ma. This will be 4mg minus 4mg over 10. This will give me 40mg minus 4mg, which will give me 36mg over 10. And that will be the value of T2. So basically, with these types of systems, you just need to know that the string is broken, so we have different tensions. Then when you get to know that tensions differ, also get to know that if the table is smooth, there is no friction. And then know where is the system going. If you've taken common sense to look at the heavier mass pulling the lighter ones, then the heavier mass will pull them in a way that it will go down. The other lighter mass, which is hanging vertically, will go up. Then the mass on the table will follow that heavier mass. But the table horizontal motion considers the tension in the strings. They are the ones which are forces acting horizontally. You neglect the reaction and the 3mg for the B mass. They can only come into play if there is friction. Otherwise, people always confuse them and they use them as resultant force and they get wrong results. So those are the examples I wanted us to discuss to accompany our definition in the morning. Any concern with what we have discussed so far? Okay, if no concern, finalize with that. Then we shall meet again on next time. Then those of physics, we can meet tomorrow, our discussion.